All right. So everybody did the homework assignment?
Of course.
Yeah, sort of early this morning.
Did you do the homework assignment? Homework assignment.
I don't know if my roommate did it or not.
Probably. Did he?
Yeah.
All right. So shut up. By the way, just in case I forget, after class today at noon is student, faculty, staff Bible study down in the terrace room. Comes with free lunch, so you're all invited if you'd like to come. You get free lunch. Just go to the cafeteria, sign your name, then go down to Bible study, just in case I forget to mention it at the end of class. Okay, so homework assignment. I introduced to you two methods last class. Methods being reusable chunks of code for accomplishing something. Dealing with strings. One was the length method, one was the char method for getting specific characters out of position within a string. So we were to write the code necessary to display the contents of our string S up here, one character at a time, and it should work for multiple versions of S. So we'll take out all this code here and just leave S up there. So we'll write a for loop. We're going to loop through every character in that string. So for int I is equal to 0, because strings are 0 indexed. The H is at bucket 0. The O is at bucket 4. But the length is 5. Okay? So I is equal to 0. I is less than S dot length. See, that's why I need the autocorrect. It went all wonky on me. You saw it happen. There we go. See? Now I didn't spell it wrong. Too reliant on technology these days. All right, so we're going to go less than S dot length because we want to go from bucket 0 to bucket 4, not all the way to bucket 5. Make sense? That's why we're saying less than as opposed to less than or equal to. Each time through, we want to print the character at that particular bucket, which is S dot char at I. And this will print out all the characters in S, one character per line. That makes sense? If I wanted to print out all on one line, I could just leave the ln off and it just won't press enter. And I can change hello to anything I want without changing anything else in the code, and it still works. Because the loop is going based on the length of the string stored within S, whatever that string is. If it's hello, it has a length of 5. If it's elephant, it has a length of 8, so on and so forth. Make sense? All right, questions about the homework? Okay, so we learned about two methods with strings. Did we actually ever answer this question, how do we compare strings?
No.
Okay, we looked at why the double equal sign doesn't work, right? Why is that? Remind me. I would hope it's somewhere in your brain, not somewhere in your notes, but it should at least be in your notes. We looked at a whole bunch of examples last time of why the double equal sign did not work, the equivalence operator. Why not?
The strings boil down to pointers.
Okay, strings boil down to pointers. That's a good start, but you still haven't convinced me you know the answer. Keep going. Or I suppose keep reading your notes. All right, go ahead.
Because it's comparing memory addresses instead of like the value itself.
Okay, so using the double equal sign is the equivalence operator for primitive types, right? And a pointer primitive type is which doesn't technically exist in Java, is a primitive type variable for storing a memory address. It exists in Java's predecessor, C and C++. Java kind of hid it away from us because it's one of these things that allows bad programmers to write really, really bad code. So pointers are really powerful when used appropriately and are really, really inefficient for beginning programmers who typically use them incorrectly. Okay, so that's why Java kind of removed them. I actually had an interesting conversation with a student this morning who is an engineering student in Madison, at UW-Madison. He's taken some computer science classes. And his intro classes, kind of this class and the class after it, are taught in Java, but some of the higher level classes are taught in C, which is kind of interesting. C being, let's call it, mostly a dead language now. Nobody really programs in C unless you're maybe writing video games, but even then you're moving away from that. But it was interesting how they teach the upper division classes in C, and I asked him, he kind of was making the argument why he thinks they do that, and it's for these details. Seeing the pointers in action. So we're talking about it in here, trying to understand what's happening under the hood. Java is a great language. It has all these conveniences built into it for us. More importantly, from an education perspective, the main reason I use Java is not because it's such a convenient language and hides all these details from you. I would probably prefer to teach your first programming class in C or C++. The real reason to use Java is because it's platform independent. All of you can do your homework and I don't have to manage what platform you're on. Windows, Linux, Mac, doesn't matter. So it's very convenient for that. Having said that, let's say that Java's the better language than C. It's an evolved version of C, but it does hide some of those interesting details from us. And it's important to understand those details because it does translate into other problem solving. So for instance, if you didn't understand the concept of pointers, trying to understand the concept of comparing strings to each other using the double equal sign becomes problematic. Because there is a difference between comparing memory addresses where a string lives and comparing the contents of the string. So the double equal sign will never compare the contents of a string. It will compare the memory address where that string exists. Is this literally the same string? Not does it contain the same characters? Does that make sense? Okay, so good rule of thumb, never use the double equal sign when comparing strings. Okay? It's flat out wrong unless you absolutely specifically mean, I want to compare the memory address of these. I have two objects, I want to know if they are indeed the same object. Okay? Not the same contents, literally the same object. Make sense? Okay, so then how do we actually compare strings? We have another method called the equals method. The equals method takes a string as a parameter, as input, and it returns for us a Boolean. Okay? And this method does compare case sensitively. Case sensitively?
Case sensitivity.
I don't know.
Sensitivity.
Case sensitivity? No, case sensitively. Compares them.
Case sensitive.
You know what I'm saying.
Sensitive.
All right. Okay, so it does take case into consideration. Ha! That sounded much like more legit. All right. I'll show you a second version of this in case you ever want to use it. There's one called equals ignore case. That takes a string as a parameter. Question, would this be an example of polymorphism?
Which one?
What I'm showing you here, these two methods. Is this an example of polymorphism? What is polymorphism?
An expression that does more than one thing.
No. You got some really small pieces of that, right? What's polymorphism? Is that a half hand?
Yeah.
All right. What is it? Are you reading from your notes or from your brain?
Can I read from my notes?
I don't care if you do, but I would encourage all of you to get some of these things in your brain. You should be studying for hours between classes. We all do that, right? We're very studious.
Yeah.
Go ahead.
More than one method with the same name that may take a different number and or type.
Parameters. So, yeah, did you write that down, or you should add that?
Okay, I will.
Yeah. So polymorphism is having more than one method with the same name with a different name with a different number and or type of parameters. Is this an example of polymorphism? Well, they're both for comparing strings, right? One takes into consideration case, the other one doesn't. Is this polymorphism? Why?
Different and maybe method.
They don't have the same name. If they were both called equals, then it would be an example of polymorphism, although this would be illegal because they both take strings, right? We wouldn't be allowed to have that in that situation. But, so these are two separate methods. Not an example of polymorphism. One of them just compares strings in terms of exact content, the equals method. The other one compares strings in terms of exact content, but ignores case. And we'll look at some ways of accomplishing that on our own today. But let's go ahead and look at this equals method. So we'll go back into our code here. We'll give ourselves a couple of strings. We'll work with hello. And we'll say string s2 is equal to hello. And we'll say string s3 is equal to new string hello. And we're going to go ahead and print some stuff out. Just as a review. S equal to s2. What's that going to display? True? Okay. S equal to S3. False. S and S2 are both string literals. So S will create the string initially. S2 will notice we already have that literal and just point to the same place. So both of these variables point to the exact same place in memory. Okay? That's why comparing these two is true. S to S3, S3 is using our new keyword, which is our real estate agent, which will override the literal default and go and create a brand new space in memory to build for us a new string that contains hello. So S3 holds a different memory address than S or S2 hold. So that's why that's false. Now, if I want to compare S to S3 in terms of contents, I'll say S dot equals S3. Notice back here in the slide, the name of the method is equals. It requires a string be passed as a parameter for us to compare the calling string to. So who is calling the equals method? S is. Who are we comparing to? The string we pass in as a parameter, S3. Does S have the same contents as S3? Is hello the same as hello? Yes. And the equals method will compare them as such. That make sense? So the equals method is comparing the contents of the string, not the string, not the pointers. If we change S3 to have a capital H, you'll see that S is no longer equal to S3 because they are not identical in terms of content. So now it's false. But if I use equals, ignore case, now it will be true. Okay? Now, an important thing to note here, because something I see with beginning programmers is you like to just make up method names that you think should exist. Like S dot do my homework, open close parentheses, just assume that exists. Almost always I'm asking you to solve problems in terms of the tools you already know. All right, so chances are there isn't going to be some crazy built-in function for doing it, and if there is and you haven't learned about it, you're not allowed to use it. So something I just want to point out here is this ignore case thing. This isn't some like built-in special keyword that you can tack on to the end of any method and have it just magically ignore case. There is actually a second method in the string class called equals ignore case that just happens to compare strings ignoring case. Okay? This isn't some sort of magic word. Okay. Now let's go to create another little slide here. We're going to call this our string toolbox. So we know about Boolean equals. We know about Boolean equals ignore case, which I actually rarely even show until it just kind of comes up. I just happened to show it to you this time. It's a convenience method, but we're going to write our own version of that. Okay. We also learned about the char method that takes an integer as a parameter and gives us the character at that position. We also learned about the length method that takes no parameters and returns the length of the calling string. Okay? Now, these are how these methods would be defined in the documentation. They would look like this. They would be omitting a word out front called static, which we've seen before with the main method, but we kind of explained it away temporarily, right? So we're going to not put them on there because they don't have them on there. String methods are all non-static methods. And that brings us to this concept of an instance method. In terms of identifying an instance method, these guys do not use the static keyword at method definition. Okay? That's when the method is actually being defined, not when we're using it. There's two different contexts for methods. One is, we didn't write the length method or the char method, but we know somebody did. Somebody defined that method for us, right? When that method was written originally, the actual logic of the method, it did not have the static keyword in front of it, which then automatically made it an instance method. We'll talk about what that means, but just right now it's a new vocabulary term. Instance methods are methods that do not have the static keyword in front of it at definition. Instance methods are called using an instance of the class in which the method was defined. So that's when we use them. Okay? When instance methods are defined, we define them without the static keyword. When instance methods are used, we call them using an instance of the method, or an instance of the class in which the method was defined. So I've told you that all these methods here, these are the definitions of them without the actual body. So the header of the definitions. That all of these guys live inside the string class. And we know all these guys are instance methods because we do not see the static keyword out front. Right? All right. Now in practice, when we're actually calling one of these methods, notice that I'm calling the equals ignore case method using an instance of the string class. S. S is a string. That make sense? Similarly, if I want to call the length method, which is also an instance method, this will tell me the length of S, which is 5. So what is an instance? We have something called an is-a relationship. For example, anything that is a string. Did I write something funny? Or just sounds funny when I say it?
Anything that is a string.
Oh, well, it's is a relationship, so it's meant to read that way. Okay, anything that is a string is an instance of the string class. So that's an object-oriented term, ISA. Didn't just make it up. Okay? It actually is a real object-oriented term. All right. We can further say that an instance is a variable which holds a pointer, because instances only make sense for objects. It's a variable which holds a pointer which points to an actual object built somewhere in memory. That is an instance in general. An instance of the string class would be a variable which holds a pointer which points to an actual string built somewhere in memory. An instance of the random class would be a variable which holds a pointer which points to an actual random object built somewhere in memory. Make sense? So an instance is anything, well, an instance of the string class is anything that is a string. Think we got it? All right, I'm about to trick you. Heads up. So, if I print out s.length, what's going to display? 5, right? The length of the instance that called the method. So s has 5 characters in it. What if I print out s2.length? 5. That's the number of characters in s2. Which just happens to be the same number of characters that's in S, because in fact, those are actually the exact same string. Not the same contents, but the identical string. So because of the way I've defined S and S2, these guys are synonyms for each other. They point to the same place in memory. Remember we did that little diagram last time? What about the length of S3? No. Length is the length of the string at the contents. But I get what you're saying. You thought because of the new keyword that now we have memory addresses. All of these have memory addresses. Every single one of these ultimately is a memory address. Every single object we ever create is a pointer that points somewhere into memory. Okay? The length method is owned by an instance of a string. Instance methods are owned by the actual instance that calls them. So the length method knows everything there is to know about the string that called it. So it knows that S points to the string hello in the literal memory, and it knows there's 5 characters in it, and prints out 5. We know that S2's length method knows to go to the literal memory where hello is, for that, which is the same place as where S was, and knows there's 5 characters in that. S3 goes to that instance, which points somewhere else in memory, not to the literal memory, but somewhere else in memory, where there is a string, hello, which has how many characters in it? 5. So this will print out 5 as well. Make sense? If I change this to elephant, now it prints out 8. So instance methods know everything there is to know about the instance that called them. Make sense? Okay, are you ready to be tricked? Seen that before?
I've seen an example, yeah.
Anybody hear a quick story? Funny story about a classmate?
Yeah.
So I happened to be playing World of Warcraft with one of your classmates last night. And he got booted from our group for being a noob. It was really funny. Even my wife laughed. We were on Skype. She was laughing at him. Thought it made my night, actually. So because I've made fun of you, we'll let you answer this question, possibly embarrassing yourself again. All right. What's going to print out here?
4.
4?
Yeah.
Is this an instance of the string? I didn't say S or S2 or S3.
Yeah, but that's what it's kind of like when you put the S where you're defining hello, it's the same thing. You're defining noob before. It's like you're looking to get that when you're doing length.
I think you know what you're talking about. Tell me a little bit more about that. If I put S there,
Then you're calling the hello. You're calling the length of hello, and when you put noob there, then you're calling the length of noob. And
okay,
it's the same thing if you define anything else. If you say v is equal to, I don't know, any word, then it's going to be the same thing that you're calling when you do.
what happens at runtime with S? When I run this program, what's actually happening with S?
Hello.
Remember we talked about variable resolution? So S is going to resolve to a value. Go ahead.
It's always going to result to the variable value.
It's going to resolve to the value the variable holds. So in this case, S is an object. Well, S is a variable. So if I were to ask you to tell me everything you know about S, you would say S is a variable. Then you might say it's a variable of type string. Strings are objects. Therefore, I know that object variables hold memory addresses. So S actually holds a memory address which points somewhere in memory where an actual string lives. So after Java does all of its magic behind the scenes, S ultimately resolves to hello. That's what ultimately shows up there. Does that make sense? And then we call length on that string because this guy is a string. We're just seeing the natural version of a string rather than something in, the professional packaging inside of a variable. This is what a string actually looks like. So if we were to print out the length of noob, I didn't have to do very much work to resolve this guy. That is a string literal, correct? So it therefore would have a value of 4. Golf clap. Good for you. You can't clap for yourself. That's just
Sorry.
noob.
Major.
I'm probably going to hear about that later. All right. So does that make sense? How these instance methods work? Similarly, if I say noob dot charat 2,
2 dots or 1 dot?
1 dot, dot. So noob.charat2, what's going to display?
Oh,
Oh, this is bucket 0, this is bucket 1, this is bucket 2. So this will display the second O. Make sense? All right, so questions about instance methods, at least in use. We haven't written methods yet. We're going to actually write one now. All right. But before I do that, let me just show you a couple of more methods for our toolbox. Just a couple more. So we'll go back to our string toolbox. We have a method that returns a string called toUpperCase that takes no parameters. We have another method called toLowerCase that returns a string that takes no parameters. ToUpperCase, what do you think that guy likely does? Gives us the uppercase version of whoever called it, right? And toLowerCase gives us the lowercase version of it, right? Why do these guys not take any parameters? Why do they not need inputs? As opposed to equals needed an input for a string. Charat needed an input for an index. Why don't these guys need inputs?
to take everything that you have inputted before or after it and changes it all to uppercase or lowercase?
It's possible that you know what you're talking about, but it doesn't sound like it. How would you call the toUpperCase method?
String name dot toUpperCase.
So for instance, like s.toUpperCase, if s held hello. So back here, if we came in here, we could say S dot to uppercase. That's how we'd call it, right? And what would you expect this to print out? So capital HELLO. Did we need any inputs to work there?
No, because it's already taken it from S.
Yeah, it knows about S. We didn't need anything additional in order for it to work. As opposed to something like char at. If we say S dot char at 1, that's going to give us the E. But we had to tell it the index. It already knows about S. It knows about the string hello. But we had to tell it which particular character we want to extract from hello. That's why we needed the additional input. Does that make sense? So all instance methods know about the object that called them. That doesn't mean we won't need additional inputs to do the job the method's supposed to do, but many methods may be able to accomplish their task without any additional input. Okay? Oh, I don't know why I was writing it up there. Just pretend like I wasn't in the middle of defining a variable. That's the completely more legit way of writing that. Okay? So we're going to say S dot to uppercase. And we're going to expect this to print out hello in all caps. Then I'm going to say system.out.println S. What's going to display? So we're going to print out the uppercase version of S. And then we're going to print out S. So this is going to definitely give us hello in all caps. What's this guy going to print out? Hello in all caps?
No, in lower.
All lower?
Yeah.
Okay, are you willing to bet your final grade on that?
Yes.
Ooh. Gambler. Anybody think he's wrong? So everybody thinks this is going to print out hello in all lowercase. Are we all willing to risk our final grade on this? Not everybody's as confident as you are. What will this print out right here?
Lowercase. Hello.
You think uppercase?
Lowercase.
Who thinks uppercase? Who thinks maybe uppercase? We got a maybe uppercase, we got a maybe uppercase, we got a half maybe uppercase. I love this. It's like, I'm not really committing, but it's more of a commitment than the people who just kept their hands down. They didn't vote either way. You know, we'd only have like about 40% voter turnout in here if we actually did the full vote either direction. So this is going to print out hello in all lowercase.
Yes. Final grade.
Why?
Because it's just calling the defined variable S that you already put up there. The string S is equal to hello in lowercase. You didn't redefine it by printing out S dot to uppercase.
Okay. How would I have redefined it? How would I have changed the value of it?
Well, you would say S is equal to, or maybe S2 is equal to S dot to uppercase.
I want to redefine S. I want S to hold a new value.
Oh, do S equal to the
That?
Yeah.
Now is it going to give us the uppercase version of it?
yeah.
Okay. We get the uppercase version now. So this guy right here is a method that boils down to the uppercase version of the string that called it. It does not permanently change that string. It just gives us an uppercase version of it as a returned value. Okay? If we look at our toolbox here, to uppercase returns a string. That's what comes firing out of there. That's what it resolves to. Whoever called it does not get modified. Now, that doesn't mean we couldn't have modified it. It just happens to be, well, since we didn't write the string class, we didn't have control over it, but when we start writing our own objects, we could have made that method modify our actual value if we chose to. But that might be a little bit deceptive, right? So we're going to have the toUpperCase method. Well, what it does is it returns the an uppercase version of the string that it originally held as a copy. Now, if I actually want S to hold a new value, I have to use the assignment operator to assign the uppercase version of S. Because at the end of the day, this whole thing here is going to resolve in a couple different ways. First, it's going to resolve S to HELLO. Then it's going to call toUpperCase on HELLO and ultimately produce HELLO and all uppercase. And then we're going to assign that value into a variable named S, which will overwrite the original value that was in S. Make sense? Okay. So now S has a new permanent value. All right, questions about that? All right. Now, we're going to write our own method. Methods. Again, reusable chunks of code that accomplish a task. We might want this for doing something. If we're going to do something throughout our program multiple times, it might be helpful to create a method to do it, and then whenever we need it to happen, just call upon the method. Syntax for methods. Return type, followed by method name, followed by opening parenthesis, followed by comma delimited list of parameters. Inputs. So parameters slash inputs. We can call it inputs if you want. The official object-oriented name is parameters. Followed by an opening curly brace, followed by a body, followed by a closing curly brace. Make sense? So that's the generic definition of a method, generic syntax for a method. So let's look at one by example. Let's say that I want to write a method that takes an integer as a parameter, squares that number, and returns the square of the number. Simple little math one, right? Now, when we write our own methods, initially, all of our methods will have static in front of them. Which takes us to our other kind of method. We've seen instance methods. Instance methods do not use the keyword static in front of it. So we'll go ahead and steal that line and modify it slightly. So class methods do use the static keyword at method definition. Well, here, I'll just type it. Class methods are called using the name of the class in which the method was defined, as opposed to using an instance of the class in which the method was defined. Make sense? So we've been calling the string instance methods using instances of strings. We would call class methods using the actual name of the class in which the method was defined. So if we happen to have a class method in the string class, If we happen to have one of those, we don't, but if we happen to have one of those, we would call it by saying string dot, the name of the method, as opposed to s dot, the name of the method. Okay? Class methods are called using the name of the class in which the method was defined. Instance methods are called using an instance of the class in which the method was defined. Add that to your things you should be, add that to your chantable list. Just like Boolean expression, any expression that boils down to a single value of true or false, right? Okay, how do you call instance methods? How do you call class methods? How do you tell the difference between an instance method and a class method at definition? One way, the word static. The word static is there when you're looking at a method definition, it's a class method. If the word static is not there when you're looking at the definition of a method, it's an instance method. That one word, if you're looking at the definition of a method, that one word tells us everything we need to know about how to call that method. Do we need to call it with the name of the class in which the method was defined, or do we call it with an instance of the class in which the method was defined? Make sense? So we're going to write class methods for right now. We're going to start writing instance methods once we start creating our own objects. The reason we're writing class methods is because we're always going to be calling them from within a static context. We only have one class to work with right now, so we're writing everything within this one class. So when we call something, we don't have instances of our class. We don't know how to create those yet. The only thing we can do is we can say HW dot square. The name of the class. The name of our class is HW in this case. Okay? So we're going to write a method that squares a number. It's going to return an int, so the return type will be int. The name of the method is going to be called square. And this guy's going to take an int as a parameter. Single value. It does not matter what you name this int. This is just a variable name. But whatever you name it here should be how you use it inside here. Make sense? And we're going to go ahead and we're going to return n times n. That's the square of n, right? If n was 5, it'll take 5 times 5, giving us 25, and return 25. So 25 will come firing out of there as the returned value. And we return a value by using the return keyword. Return keyword. Syntax is return followed by a value, followed by a semicolon. This immediately ends a method returning value as a result. The important thing there, the most important thing here, is this idea that it immediately ends a method. Every method will have a return type. Methods that do not return something will have a return type of void. Go back to our methods. What can return type be? Return type can be anything. We can create a variable. I'm going to say of, it's a dangling preposition, but whatever. Close enough. You get the meaning. Anything we can return and we can create a variable of. So that's all of our primitive types. It's all the object types that are built into the language, as well as all the object types that we're going to that we can write on our own, which is literally an infinite number of things we can have as return type. Correct? We have a very limited number of them right now because we don't know how to write our own objects, but return type can literally be an infinite number of things. If or void if we are not going to return something. In older languages like C, we had two different types of methods. Methods that returned a value, methods that did not return a value. Methods that returned a value in C were called functions. Methods that did not return a value in C were called procedures. Okay? This is all just naming convention stuff. Functions returned a value, procedures did not. In Java, everything's called a method. Some methods return a value, some methods do not. Methods that do not return a value will have a return type of void. And if it has a return type of void, we should not have the return keyword in there. Now, that's actually a slight lie, but just believe me for a while. I'll even give you a little hint. The reason it's a slight lie is because of this one little piece here. The return keyword immediately ends a method. So if you have a method that returns void, returns nothing, we could potentially prematurely get out of the method using the return keyword without any value. Because return essentially kills a method. We'll see some examples of that, but that would be an example where you might have the return keyword inside of a method that has a return type of void. But if it has a return type of void, you would never have a value following the return keyword. But for our intents and purposes right now, if you have the return type as void, don't have a return value. Don't have the return statement anywhere inside of your code. All right, so this method takes in a single input, n, whatever that variable is. So whoever calls this method is going to pass it a single input. If they pass it a 5, this will return a 25. If they pass it a 4, this will return a 16. If they pass it a 2, this will return a 4. So on and so forth. Make sense? So this is our parameter, and it's a variable because whoever calls this method might pass it different values. And we will return n times n, which just happens to be that value squared. Now, is this a class method or an instance method? This is the method definition we're looking at. Class method or instance method?
Class.
How do you know?
Static.
Static. It's a class method because at its definition, it's defined using the static keyword. How do we call class methods? We need some chanting music. We call class methods using the name of the class in which the method was defined. Okay, what's the name of the class in which this method was defined? HW. That's the name of our class. Name of the method is square. Name of the class is HW. So I'm going to print out HW dot square, and I'll pass it a 5. And that should print out. Here, let's just get rid of this extra crap here. That'll give us a 25, right? Similarly, I can go right on the very next line and I can call that method again, passing it a 4. So the first call to it, 5, gets passed in for n. We'll multiply n times n. Each of those n's will resolve to the value that it holds, which is a 5. 5 times 5 is 25. It will return that value as an int. So if you return an int, don't try to return a string. If you've advertised you're going to return an int, you better return an int. Okay? Furthermore, if you've advertised you're going to return a value, make sure you return a value. And I'll show you an example of that in a second. Okay, so the first call to it, we're going to say square 5 for us. The second call to it, we're going to say square 4 for us. So same reusable chunk of code with 2 different inputs. Gives us 2 different values. Make sense? Now, let's say that we only want our code to work for positive numbers, as an example. I might throw an if statement in here. I might say if n is greater than or equal to 0, then return n times n. So now our code only works for positive numbers, but notice that Eclipse is not happy. When I hover over that, it's going to say this method must return an integer. This method must return a result of type integer. Well, I have right here, right? Aren't I returning a value? This method conditionally returns a value, right? I only get to this line right here if this Boolean expression boils down to true. If that Boolean expression right there boils down to false, I fall past that method to right there. And there's no return statement. So in order to make Java happy, I would have to put some sort of return statement here. Maybe I decide that the output is -1 in the event that they gave me a negative number. You don't need an else. Why not? Well, no, it's an important lesson though. Why don't you need an else here? What does the return statement do? Immediately makes the method end. Immediately. I'm only here if I avoided this bomb. Okay? So if I hit this Boolean expression as true, I'm going to multiply n times n, and this method's over. All this other stuff down here gets disintegrated. We never get to it. If I get to this line here, it's like this stuff never existed. Because I got past it. I never executed the body of that if statement. And I'll just return -1. Now, having said that, does it change anything? Me putting an else. Does that change the logic of this at all? In this particular case, no. If this is true, do this. If this is false, do this. Which is the same thing that happened before. Correct? So it's not incorrect in this case to do the else. But it's not necessary. Okay. So questions on writing our own methods. Right now we only know how to write class methods. So what if I wanted to write a method called display string, basically our homework assignment? Well, we're always going to put static in front. Remind me, what did our homework assignment do? We created a string and we displayed the contents of that string to the screen one character at a time, right? We displayed it to the screen one character at a time. What's the return type of this method going to be? The name of this method is going to be display, and it's going to take in a string as a parameter. Whatever string I pass it, it's going to display to the string, display to the screen. What kind of value should our method return?
Char.
Why a char?
It's only returning one variable from the string, so like one letter from the string at a time.
Okay, and it's returning that value? Or is it displaying that value to the screen? If I pass in hello for S, what do I want my logic to do? I want to display it. So I'm going to say for int I is equal to 0, I is less than s dot length, I plus plus, system.out.println s dot char at I. That's the logic for displaying it, right? What kind of value am I returning? Okay, why a char? And then somebody else can tell me why he's wrong. Common mistake.
Okay. I was thinking because char at would display as a character.
Yeah, it's a common mistake to have problems differentiating between displaying something and returning something. Okay, displaying something to the screen is not returning it as the value from our method. It is just spitting it to the screen for output. Okay? We only return something if we're going to use it for something else. So for instance, if I wanted to write my own version of char at, static char stupid copy of char at. This guy's going to take a string as a parameter and probably also an int index, because I need both of those pieces of information in order to do it, right? And then I might have this guy return s.char at index. This is actually getting a character from S, the character that lives at index, and we are returning that as a char. Nowhere in here does it necessitate that it gets displayed to the screen. We're returning it. Here, we're displaying some stuff to the screen. And unless there's a reason to return a value, our return type should be void. By the old C definition, that's a procedure. It takes 0 or more inputs and does something, but doesn't necessarily return a value to you. Maybe it calculates something and spits the result to the screen. So you might write a method called display menu, something like that. That just every single time you want a please enter your name and then whatever else after it. If you want to have a menu of options, every single time you need to display that menu, you'd call your little display menu method, and that method may not return anything. Its only purpose is to display a bunch of stuff to the screen. But if you have this big long menu that's 30 lines long, rather than having 30 lines of code every single time you want to display the menu, you call this one method. Display my menu. Display my menu again. Display my menu again. Every single time. Okay, so displaying something to the screen is not the same as returning something. All right? So our display method here takes a string as a parameter, spins through every character in that string, and prints that character to the screen. That's it. Nothing's being returned. I'm about to trick you. Everybody paying attention? How do I call the display method? What kind of method is it? Class method or instance method? How do you know? Static. It's a class method because it has static in front of it. How do we call class methods? Using the name of the class in which the method was defined. What's the name of this class? HW. So I call this method by saying HW.display, right? Now what does this method require to work? I have to give it an input. This guy requires a string to function. All right? Kind of like you want bubble gum from one of those machines that requires a quarter. This guy requires a string to do its job. All right? So we'll put hello in there. What's wrong with this line? No, it's inside main. All programs begin and end with main. So there's main right there. All this guy is saying is go call this display method, which is inside of the class but outside of main. So we're fine there. What does the println method do? Here, let me untrick you for a second. What does the println method do? What's its job? If you had to concisely define what println does, what would you say?
New lines.
Huh?
New line.
It does involve a new line, but what happens before the new line?
Displays everything.
Display something, right? Whatever you got in there, it displays that value. We've seen that when we used our polymorphism example, we saw there's a whole bunch of copies of println, right? Now, the reality is he may have actually been right depending on if he was guessing or actually came from some knowledge of it. There is a version of println that takes no parameters that just kicks something down a line. So that actually does exist. So technically your answer was right. Did you know that or were you guessing?
Guessing.
Okay, good. Yeah, but know that that does exist. There is an empty version of it that just kicks it down a line. I rarely use it. If I want to kick something down a line, I usually just print out an empty string. I think it's just clearer rather than having to remember that there's this empty argument version of it. Okay, but punchline here is that println displays something to the screen, followed by a carriage return, right? Pressing enter. What does our display method do? What would you say our display method does if you had to concisely define that? Okay, takes a string as a parameter and displays that string to the screen one character at a time. What does it return? Nothing. What does this boil down to? Nothing. Does it make any sense to try to print nothing? If I highlight over println, this method, println, is not applicable for argument void. So how do I call this method? The method is doing the printing. I don't need to call methods inside of the println statement. I could just call a method. What do you want to do? I want to print hello. Do you have a tool that knows how to print hello? Yes, I wrote it. It's called display. It's a class method, so I call it using the name of the class in which it was defined. So if I want to print out this string, I just call hw.display, and it will call this method and do whatever magic is inside of that method. Because that guy does not return a value, it makes no sense for me to try to print nothing. Does that make sense? When we've been calling methods before this, system.out.println hello.char@2, for example. This will give us, this is 0, this is 1, this is 2. So this will boil down to the char L, right? All that code in there ultimately boils down to that, the char L. If we print out the char L, it'll display L to the screen. System.out.println is a tool for displaying whatever is inside here to the screen. It has nothing to do with calling other methods. If the method that you're calling happens to return a value, and you happen to want to display that value to the screen, then you would use the println method. Similarly, I could create a char C is equal to hello.char@2, and then I can print out C. What's the advantage of doing it this way versus just printing out hello.char@2? Forget about this line for a second. What's the advantage of doing these two lines like this as opposed to that? What value does C hold? Okay, it'll hold an L. And this will print out that L. What does this line do? What will be the output of that line? What will display to the screen? This part's not a trick question. L. So both of these will have the same output to the screen. But this first one gives us the opportunity to use this value again. I stored the value that the method returned in case I need it for something else. This one just displays it, now it's gone. All the work that that method may have done has now been lost because I didn't store the result anywhere. So when do we use variables? We use variables whenever we need to use the result use the result more than one time. Does that make sense? So use a value more than one time as it relates to methods when we need to use the result more than one time. All right, so here's just our call to our display. HELLO. Questions about that? For homework. Write a method called print reverse that takes a string as a parameter and displays that string to the screen backwards. Write a second method called reverse string that takes a string as a parameter and returns. Oh, wait. I can't have you do that yet. Here, I'll just leave it at that. So make sure to test your method by calling it with multiple strings from within main. Make sense? So this is pretty much the same assignment you had this last class, except you're displaying it backwards and you're putting the logic inside of a method. Make sense? And then prove you can call that method by testing it. I will see everybody on Thursday. Don't forget about Bible study. Starts at noon in the terrace room. Just go to the cafeteria, sign your name that you're coming in for Bible study. You get free lunch, and take your tray down to the terrace room. Yeah, they all have 100 points.